Boa noite a todos, é um prazer estar aqui de volta com todos vocês. Semana passada tivemos essa semana de descanso, mas já estamos de volta com uma programação super bacana para o mês de março. Hoje nós temos um convidado internacional conosco, que vai discutir conosco sobre o risk management, e tenho certeza que será uma apresentação muito interessante para todos vocês que estão aqui. Como sempre, eu sou Marina Ferrara, advogada especializada em direito minerário e em política nacional de segurança de barragem, e comigo, como esteve em todas as demais semanas, e estará comigo até o final dessa jornada, a Rafaela Baldí, que é engenheira geotécnica especializada e que atua constantemente com projetos e operação e monitoramento de barragens de mineração, usos hídricos, enfim, usos diversos. Conosco hoje nós temos o Siefko. Siefko, eu estou introduzindo para todos vocês em português, mas a partir do momento que eu o apresentar, toda a nossa discussão, a apresentação dele e o nosso debate de hoje será em inglês. Como estamos ao vivo, não foi possível incluir legendas, mas depois do vídeo disponível, nós tentaremos, não posso prometer, mas tentaremos colocar legenda para que a gente possa alcançar o máximo de pessoas possível e para que o máximo de pessoas possível tenha acesso ao conhecimento que esse profissional que está aqui conosco, que é referência mundial sobre o tema, para que vocês possam aproveitar o máximo possível de tudo que ele está trazendo para nós, tá? Mas então, sejam muito bem-vindos de novo e vamos para mais um bate-papo semanal sobre questões relacionadas a barragens e a gestão de risco e segurança de barragens no país. Bem, apresentando o Siefko. Siefko is an engineering geologist with 25 years of working experience. He has a master and PhD degree in engineering geology from the Delft University of Technology in the Netherlands. He's chartered engineer from the Royal Netherlands Society for Engineers and is chairman of the Dutch Professional Association of IAEG and ISRM. Siefko is also a member of the Dutch National Commission on Mining Damage, and he is a representative of the consortium I4 Dam Safety, a cooperation of Dutch, Italian, and Brazilian companies that want to help mitigate risks related to the stability of mining tailings facilities. Siefko, thank you very much for your kindness. I know it's late in Europe, as you are. Thank you very much for your kindness. Thank you very much for your availability to talk to us. We know, I read here your resume. It's a fantastic resume. We know that you have so much to bring to us. So thank you very much. And please feel free. That's your time. Do your presentation, and then we go to the questions. Okay?
Yes. Thank you, Marina, and thank you for the opportunity for me to talk here in this platform. I'm very honored that I can speak here. You introduced me well, so I don't have to introduce myself any further. I had, in 2019, I visited Brazil 3 times after the Brumadinho disaster. And 2 times I was sent on a mission by the Dutch government. It was a disaster risk reduction mission to advise the National Mining Authority in Brazil on the issue with mine tailings. And we were there with a large team with geotechnical background and also with risk management background and geological background, which I have. So I want to talk to you about risk management, because everybody's talking about risk, and I think it's good to first discuss. Let me see if I can move forward. Yeah. So talk about the risk and take a few steps back, because a lot of people talk about risk, but there's a lot of terminology in risks that are a bit confusing. So I think it's good to take a step back and talk about risk in general. And then I want to dive a little bit deeper into the issues with tailing storage facilities in the state of Minas Gerais. How can we use the information that's available from the different databases? And how can we use, for instance, a tool like GIS to determine the impact of dam breaks? So hazard and risk, because these terms are interrelated and they're often used interrelated, but they're different things. And a very interesting definition of risk is in a new ISO norm, is that it focuses on uncertainty. Yeah? So a risk is actually that there's lack of knowledge, and that's an interesting point of view, because especially with the tailing storage facilities, the main issue is lack of knowledge. We don't know a lot about these tailing storage facilities, and that's the core issue, I think, in this in the risks related to tailing storage facilities. And the normal terminology is that risk is a combination of the hazard times the vulnerability and the exposure. And the hazard, that's the damaging phenomena that could lead to damage. So in case of tailing storage facilities, that's a large-scale dam break. And the risk is a combination of that damaging phenomena combined with the vulnerability and exposure. And so the exposure is the number of elements at risk, how many people are living downstream of a tailing storage facility, are there many properties, and also how vulnerable are these communities and people to this damaging phenomena. So it's good to separate hazard, the damaging phenomena, from risk. And when you do a risk assessment, because that's the start of risk management, these are the things that you need to do. You first have to identify what is your danger, what's your threat, and therefore what is your hazard, and what are the causes of these hazards to occur. What triggers the hazard? And very important as well, the consequence analysis. So what's the vulnerability and exposure of this damaging phenomena? So in the case of tailing dams, how many people are living downstream and what are the elements at risk? Roads, houses, hospitals, etc. And then you combine the hazards, the consequence, and uncertainty into a risk assessment. And then you have to evaluate the risk. Do we find this risk acceptable? You need to have a certain appetite for risk. Do we accept that risk, or are we as a society or community, are we not at all accepting this risk? So if we don't accept the risk, we have to do something about it. We have to prevent the hazard from occurring, or we have to mitigate the consequences. But to many people, I think these are logical things, but I think it's good to in this discussion to rephrase them. So how do we do this risk assessment? In this ISO norm that I talked about, there are a lot of risk assessment techniques. There are qualitative risk assessment methods, especially for dams. You can do a bow tie analysis. I can show an example of that later. You can do quantitative risk assessment for dams, event tree analysis, combination of all kinds of causes. You can do all kinds of advanced statistics and Monte Carlo simulations. And specific for tailing storage facilities, you want to do a risk model. You do a risk hazard assessment, and that is basically it boils down to a geotechnical stability analysis. Because the issue with tailing storage facilities, it's a geotechnical issue. So you have to do a geotechnical stability analysis, and especially there, the lack of knowledge plays an important role. You need to understand the material. You need to understand how the dam was constructed in the past, and that's a very fundamental part of the risk assessment. But also the consequence modeling. So if the dam breaks, what are the areas that are affected? Then what they often do is a debris flow model by simulating how far a debris flow, because that's basically what happens there. The liquefied part of your tailing facility will flow downstream and will cover and affect areas downstream. And you can do also a simple GIS analysis. Now I'll give an example of such a GIS analysis later. And yeah, to visualize what the risks are, you can combine the hazard, the probability of occurrence of this potentially damaging phenomena, and combine it with the consequences. And then you can plot it in such a relatively simple risk matrix, but it's very effective to visualize risks. For instance, if your hazard, the risk of the probability of occurring is very high, and your impact is also very high, then you're in the highest category. But if the hazard is high but the impact is low, there's, for instance, there's nobody living downstream, so there's no loss of life or loss of property, then the risk in from that point of view is also very low. You may have an environmental risk, because your environment is damaged, but from a property point of view, your risk is low. So in this way, you can visualize risk and also set boundaries. Do we find that acceptable or not? In industry, they use these terms ARP, as low as reasonably practical, because you cannot minimize all risks. You have to accept a certain amount of risk. But yeah, as a society, we may not. We may have higher standards. We don't accept any failure of these dams, for instance. So. But this is a good way of communicating risk, and also a good way of discussing about what's acceptable or not. Yeah, this is just another example. There's so many of these risk matrices that are used. This is from the Canadian Tailings Guideline, published in 2019. It's a very important document for this. For the mine tailings. And another way of looking at risks is with a bow tie analysis. And this bow tie analysis is very often used in the oil and gas industry, because they've had in the oil and gas industry very large events in the past, large blowouts, in the Mexican Gulf, and it's often a combination of all kinds of events that have taken place. And in this bow tie analysis, it looks like a bow tie that you wear. On the left side you have the threats, and on the right side you have the consequences. And the hazard, that's your main damaging event over which you do not have control anymore. In our case, it can be a dam that fails. So in this way, it gives you a very structural way of looking at your risk. And in the green section, you can see the preventive controls. What are the measures that you can take to prevent this hazard from happening? And what are the recovery controls? What can you do to minimize or mitigate the consequences? So this is in the MEC tailings guideline, what I've told you about, the Canadian guideline for tailing management. They have done such a bow tie analysis, and you can see on the left side they call it hazards, but it's not the right terminology. You should call it threats. And these are the threats that can lead to the main event, the major event, which is a dam breach. In case of mine tailings. And you can see a lot of hazards or threats actually at the left side that can lead to this major event. And you can have also controls, for instance, monitoring, or you can do decommissioning of dams, all kinds of ways of minimizing to prevent the event from happening. And then you can have also on the right side, you can have your mitigating actions, emergency plans, etc., to minimize the consequences to loss of life or loss of property. So the bow tie analysis is a very powerful tool of analyzing your risk as well. And this is the more formal way of doing your bow tie analysis. It's actually an actual detailed analysis that you need to do. We've done this exercise about 1.5 years ago when we were in Brazil with people from A&M, and it gave them a very good way of getting more grip on this issue. Because if you have a threat, for instance, a lot of rainfall, what are the ways to prevent this threat from leading to the top event? Or you have an earthquake, what can you do to prevent that earthquake from happening? That's often not possible, but what triggers, for instance, liquefaction, and that which leads again to this top event. So it gives you a very structural way of looking at your risk. And also at the right side, at the consequence side, what are the ways to prevent the impact? And at the moment, I know they're constructing large barriers to prevent the mud flows from reaching populated areas. It's a very drastic measurement, but it's a recovery barrier on the right side to prevent, if a dam fails, to prevent loss of life and property. And an important discussion is what risks do we find acceptable? And I've shown here a few illustrations. I don't know if they're very clear. The reference from which I took it are on the upper right corner. But on the horizontal, on the left side, you see an illustration of large events. And on the horizontal side, you see the amount of money lost and the number of lives lost in the logarithmic scale. And the vertical, you see the annual probability of failure. And the normal guidelines and norms say that you cannot cross this line that you can see here. And so if you're in this area, risk is generally not acceptable, also according to all the norms. On the left side, the lower left side, these are the events that have taken place. And if you talk about mining, and mine pit slope failure happens quite frequently, maybe once a year or once every few years. But there's in general not many lives lost and not much money lost. But large dam failure do not occur very frequently. But if they occur, the impact is quite large. So this illustration is based on a lot of events that happened in the past, and only when they exceed this line, these two lines here, then in general terms we do not find this acceptable anymore. And this is a bit more clearly illustrated on the illustration on the right. On these two dotted lines are the risks that international standards and guidelines normally follow. But when the number of fatalities and the probability of occurrence exceed this line, then we do not find this risk acceptable anymore. And I think that's exactly what happened with the two failures in Brazil, with Brumadinho and the Samarco failure before that. It happened a few years after each other, and the number of fatalities was so much that these two events, it was falling in this range. So it's normal that as a society you do not find this risk acceptable anymore. And so a way of determining the safety of tailing dams is by using in geotechnical terms, a factor of safety. And it's also, I believe, it's in the law in Brazil that you have to satisfy a certain factor of safety. And it's often used to express the safety margin of the stability of dikes, dams, embankments, etc. It's the equation between the resistance and the load. So if the resistance is higher than your load, then your factor of safety is more than 1. So in principle, your dam is stable. In most norms and codes, we find that the minimum factor of safety is about 1.5. In some more modern codes like Eurocode, they don't use factor of safety anymore, but instead they use partial factors on the properties, geotechnical properties, or on the load factors. And in your calculation, you have to come to unity. The sum of your equations should become 1. So that's it's actually the same approach, but a different way of calculating. But your factor of safety should ideally incorporate all kinds of uncertainties. And then I come back to the statement I made before from the ISO. Uncertainty plays a big role. Uncertainty, especially in geotechnical terms, about shear strength, your loading conditions, and the consequence of failure is also uncertainty. How much area will be affected downstream. Ideally, your factor of safety should also incorporate that. But in practice, only the loading conditions, so the geotechnical loading conditions and strengths are incorporated. And from a practical point of view, a minimum factor of safety of 1.5 is generally recommended. I think in Brazil it's 1.4. But factor of safety doesn't always say everything. It doesn't give you the ultimate answer. Because there's uncertainty. There's uncertainty in your load and there's uncertainty in your resistance. So how much capacity does my dam have and how much load does my dam have to take? It's not a fixed value. There's a certain probability of having this value. And you can see even if you have a factor of safety that satisfies your norms, for instance, your resistance is 1.5 higher than your load, there's still a probability, there's still a chance that failure occurs when your resistance is lower than your load. So you still have a probability of failure, even if you have a high factor of safety. It doesn't mean that your dam is always stable. There's still a chance that failure occurs. So so what is needed to reduce the uncertainty? So you need to know more about your tailing storage facility and about your dams. Because this is also an interesting illustration. It goes a little bit maybe very technical now, but it shows that if you have a high factor of safety, it doesn't necessarily mean that you have a safer dam. Because if your uncertainty is larger, for instance, here you have a factor of safety that is 1.8, but your uncertainty, your probability distribution is quite wide. So there's still a larger probability of failure than in case where you have a lower factor of safety, but a smaller uncertainty. So it's maybe a bit complicated for someone to follow, but the key what you have to remember is that uncertainty is very important. And this is also an interesting illustration that the probability of failure also depends strongly on the quality of your project. So this gentleman, Silva, has analyzed a lot of projects where failure has occurred and related that to the factor of safety. And similar projects or different projects with different quality which have the same factor of safety have a different probability of failure, and that makes sense. So a very well designed dam with a factor of safety 1.5 has a much lower probability of failure than a poorly designed dam, or a dam that's not designed at all, just constructed, but which, according to your geotechnical calculation, has the same factor of safety. So in terms of standards and guidelines, there are a lot of standards and guidelines for risk management. You have the Untitled guidelines for the dam, world of dams. For dam design, you have the MAC tailing guideline that I showed you some examples from Canada. And recently, Rafaela told me that there's an update of the Untitled guidelines on tailing dams. And the Eurocode, we used Eurocode 7 for geotechnical design and Eurocode 8 for earthquake design, which I think are relevant norms and guidelines for tailing storage facilities. So now I show you an example of how you can do a risk assessment. So I go now for high level to more low level. Not low level in terms of quality of this work done, because it's done by Monica Novel-Morel. I hope she's following this presentation right now. She's an intern with our company, and she did an assessment of what happens after a dam break study, but using a quite basic, simple approach. First, she assembled all the databases of the tailing storage facilities, because I personally was interested where are all these tailing facilities located. And there are several databases, FEAM and ANA and ANM have databases which are publicly accessible. And she assembled those databases. And she found out there's also some discrepancies between those databases. But they're all unique databases using different kind of information, and she assembled that into an Excel database and a GIS database. So you can, I made some screenshots of this GIS database, and you can see that around Belo Horizonte there's a lot of tailing storage facilities. And again, this is public available information. And this is a different way of looking at it. This is in the background, you see a digital train model, which to the analysis of to the flow analysis and dam break analysis, digital train model is very important. This is an example of how the databases were integrated. I will not go into too much detail because I think I'm running out of time a little bit already. But the approach that was used is to use a relatively simple empirical relationship to determine the angle of reach of debris flows. Because from the database you can determine the volume of the tailings behind the dam. You can determine the height, because it's also available in the database. And using the digital train model, you can then calculate how much theoretical runoff you could have. And this is based on an empirical relationship developed by Corominas back in the 90s, where he investigated many debris flows, and based on all the past debris flows, he determined the the energy angle, so to speak. And it's basically the energy angle is based on the volume of material. So if you know the volume of material and you have the height of your dam, this h, you can determine in theory, you can determine your run out. Yeah, and in illustration, it shows you this concept of energy plane. That's the red line. So all the material that's stored behind a dam, if that starts to move, and when it moves, it usually moves in terms of a debris flow, it will follow the energy line. So when the topography, when it's illustrated with a straight line, but the topography, of course, is undulating. So when your energy line crosses your topography, that's the reach of your runout. So your runout will not flow further than that length. It's a very theoretical concept, but it's based on actual debris flows that were measured in terms of runout distance. So if you use that, this is an example of one of the tailing storage facilities around Minas Gerais. When you know your storage facility, you know the alignment of your dam, and when you have a digital terrain model of the area downstream of your dam, you can calculate how far theoretically your debris flow will reach, because it will follow the area of the energy line, and when the energy line intersects the topography, this is where, in theory, your debris flow will not flow further. And by using your digital terrain model, you can also calculate your flow path. So in theory, the debris flow will not flow further than this purple line here. So in this way, you can relatively easily, without having to do very advanced flow modeling, you can relatively easily calculate flow paths. And this is just for 3 examples. But because in our database we have all the dams, we know where all the dams are, we know the heights of the dam, we know the volume of the dam, and with a digital terrain model covering the entire area, you can in principle calculate this for all your dams. So in terms of risk assessment, I think this, in my opinion, this is a very important first step to see, okay, where are my potentially damaging storage facilities, and in case they fail, how far can the mud flow reach? Yeah? And then combining it with populated areas, the number of people that are living in areas, you can actually calculate what are the highest risk categories, but from a different point of view than what is done now. So that is my presentation. So I also presented on behalf of Monica. She did that study that I presented to you. So muito obrigado, and I hope there are some questions.
Thank you very much, Siefko. It was a very interesting presentation. I'm a lawyer, so even as a lawyer, I could enjoy and understand a lot of the aspects that you present to us. But I'm sure that Rafaela was getting more from you. But we have already some comments and some questions from our audience. But before we go to our audience, if you let me, Rafa, I would ask Siefko, in your presentation, as a lawyer, of course, I will bring the subject to regulation for sure. You showed us there are some guidelines and standards related to risk management, right? Some international ones, but in regulation perspective, is there, or is this subject regulated, and how is it regulated in the main European countries, or in some countries that you think are more advanced in their regulation? How do you see this?
Well, in Europe, let me take the example of the Netherlands, huh? Because I live in the Netherlands and I know what happens here. And in terms of mining, because in the Netherlands we also have a lot of mining. We had coal mining in the past. We still have the after effects of coal mining. We have gas and oil extraction, and gas extraction in the Netherlands has led to induced seismicity, and it caused a big problem. We had a lot of damage to houses in the north of the Netherlands, because in the north of the Netherlands we have one of the largest gas fields in the world, and over 50 years large volumes of gas have been extracted. And that has created earthquakes, induced earthquakes, and that has led to a lot of damage to houses and subsidence as well. So in the Dutch, we in the Netherlands we have the mining law, and the mining law states that all mining activities are permitted until damage is created. Yeah, so a mining company can lose its license by the Dutch regulator, mining authority, which is the equivalent of the A&M. And they have to comply with the mining law, basically. So they can lose the right to produce, the right to produce or to extract oil or gas or any other mineral if damage is created. On the other hand, in terms of mining facilities and dams and so forth, we do not have large dams in the Netherlands because we are a rather flat country. But we have a lot of dikes, and the dikes are similar to the tailing facilities because in a way that the dikes in the Netherlands protect us from flooding, because the half of the Netherlands is below sea level. So if there's a big storm and the dikes break, all the big cities in the Netherlands will be flooded. It will be a huge disaster, a huge risk. Therefore, we are very strict in the safety with regards to our dikes. So they have to be able to withstand one every 10,000 year storms, high water, because in 1953 we had a huge flood in February 1953. So we have learned from the past, and we are very strict in the safety of our dikes. And the dikes protect us from flooding, but the approach should be actually similar to the tailing storage facilities or the tailing dams in Brazil, because the tailing dams threaten your population if they fail. But the failure mode, from a geotechnical point of view, is quite similar to the failure modes of dikes. And so the approach towards the safety of the dikes in the Netherlands should actually be the same approach as the dams in Brazil.
Rafa.
Yeah, I would like to put something in this question because, from my opinion, we have a big delay, of course, that if you try to make a comparison between the regulations that we already have in Brazil and the regulations that we have around the world, we have a delay. And for me, the biggest issue is that we don't have a technical obligation or a recommendation or a guideline or a technical manual, something that make our obligation to use risk tools or risk analysis in process and projects. Okay, we have this safety factor that sometimes I think that it's like a rabbit that you take from the hat because they have this magical number and they think that is the number that it will save lives and they will improve the stability. But I like to discuss about the international guidelines because you can see that they have an advance in these questions. And when you think about the dam safety declaration that we have about dams, we have established some pillars, some things that would be good for dams. And for example, you can say that a comprehensive dam safety approach will allow minimization of risks and you have another one that say that design intrinsic risks need to be adequately addressed. And every time we are talking about risk. If you go to the Australian code, that in my opinion, it's one of the most complete that we have, and we are talking about 2008, and not so young like the other ones. We have some recommendations about risk too, and you can see these topics in the Canadian and the UK guidelines and all the other guidelines all over the world. And so my question is more about risk and. In your opinion, in your vision about risk management, how can you see this delay in the Brazilian regulations and how deep this can affect the assurance of our work there? Because, like you show it in a very nice way, we have the consequence and we have the threats. How would you be our consequence if you don't wake up and start to treat these threats?
Yeah, it's a big question, Rafaela. Of course, you have a delay because that's normal because this issue wasn't there before, and now you're confronted with this issue. So you have to learn. And in the same way, we have also learned in the Netherlands, and we're still learning to take the example of the Netherlands again, because the example of the dikes is still relevant because we have very strict standards for our dikes, but there's still a lot of dikes that we don't know how safe they are. Because a lot of the dikes are remnants from the Middle Ages. They were constructed in the Middle Ages, and we do not know much about it. So even though we have high standards, there's still an uncertainty. There's still things we do not know about these dikes. And I think that's the issue also in Brazil. You can adopt very good norms and standards, and I think that's very good to do, and it's very wise to do, because you should not invent things yourself when there are very good norms and guidelines around. But at the same time, you also have big uncertainty because a lot of the dams in Brazil, you do not know how their behavior is. So just adopting standards and norms and setting high safety factors doesn't reduce your risks, because you need to investigate very carefully and very well what the conditions of these dams are. So the knowledge about these dams, I think, in my opinion, is crucial, much more than norms and standards.
Yeah, we try to be strict because we have some kind of regulations. Of course, that even we have this delay about risk management, we have laws, and the laws all the years are being a little bit better in this context. And be strict, okay, it's nice. We have to be strict. You need to consider these things, especially because when you talk about dance, we are talking about natural materials. So this lack of knowledge for us, it's a little bit more deep, because sometimes we don't have a database from projects. We don't know the things that you use it to make this slope stability. So it's so deep in this way how you construct and you do the operation. So I agree with you. You have to be strict, but I think that sometimes because you don't have this thing so deep that you can lose the license, we can go to the jail because you have the process going all over the years. We have a tendency to have a flexibility in these mandatory issues. Be strict, but I really believe that it's the biggest issue, and it's something that can happen, and I hope that happens soon.
Yeah, but to add to that, you can be very strict and you can comply with all the regulations, but it should not give a false sense of security. Yeah. So So you always have to be very critical about your calculation methods and the input of your methods, of your calculation methods.
Yeah. I learned that the geotechnical people are people that never trust even themselves. They always have doubts
You
about the.
always doubt, yeah, and that's good, because if you are confident, it's not that's a negative. If you're overconfident, that's something not positive.
Yeah.
Siefko, we have a question from our audience. Dominique, that is here with us in almost all of our lives, or in all of our lives, asks us, the structure depends on the quality and construction of the barrier, but considering the risks of the terrain, erosion and sand soils, let me put it here. What would be the size of the evaluation radius for a correct construction?
I'm not sure if I understand the question correctly. Is it about the barriers downstream, the barriers that are built downstream of the tailing
Yeah.
dam?
It's if I understood, it's about the downstream area. How is the kilometers or how many meters you need to consider, and if there's a percentage like it is. If my dam is 10 meters, how would be the percentage?
Yeah, I think that's the result of a very detailed flow modeling. Um, I'm not aware of how this is done, um, but the flow modeling basically simulates the debris flow resulting from a massive dam failure. And in that flow model, you design a barrier in order to prevent the flow from reaching downstream. I think it's a very complex study. You can do that with specialized numerical models, but I'm not aware about the details of these models. Detailed numerical flow models, I think, which you can use to determine. That's what the gentleman is asking.
And talking about this failure, I will enjoy that this guy made this question. And if you think about it, this last two big failures that we had recently in Brazil, it's clear that a proactive approach it's mandatory to the reaction approach. We don't do risk analysis, of course, for things that are in emergence, but in my understanding, yeah, we do risk analysis for things that aren't in an emergency status, and you need to avoid this situation. Do you agree of this, or it's more like a dream that I have to think that about the mining industry? We can still think about this proactive understanding and behavior.
Yeah, I think because how many tailing storage facilities do you have in only the state of Minas Gerais? There are hundreds, and of many, there's not much known, and there's also no owner anymore. I think that can be a bigger risk than the active tailing facilities that everybody knows, and that are still being used. So I think you have the sleeping giant, so to speak, that may be a bigger risk than the active tailing storage facilities that everybody knows and a lot of information is known about. I think you should also look at especially the larger facilities that are not well known and especially do not have an owner. So I think to be proactive, I would also like to focus on those dams, not only the well-known dams.
Marina, can I continue my questions because I have a lot. And,
Please.
just to discuss a little bit about this work that Monica done because it was a huge work try to especially for foreign people trying to understand all this mix of letters that we have inside the regulation in Brazil. We had some discussions about the quantity of mechanisms for dam classification, and now it's a clear understanding. You have the federal system and the estadual system, and for Minas Gerais, the things are a little bit more strict because you have these two systems that fight in a good sense for give different classifications for the dams. And when Monica was doing this work, this huge variety of system can affect a database. How she felt with this 10,000 of different numbers regarding for the same dams, and how she figured out to try to combine this data and try to understand why we have sometimes one dam that are in two locations, or one dam that have two names or two classifications. And based in this work that she done, what it was the recommendation to pay more attention about these questions in situations that are related with safety questions.
Before Siefko answer you, just to show you, Siefko, how is in Brazil, we developed in the past 2 years, we developed a book uniting all the acts related to dam in Brazil, dam safety and so and so. All, not only on federal, but also in our states. And in Brazil, we have more than 140 acts all over Brazil regulating the same subject. And as Rafaela told you, in some cases with different classifications and different times or in obligations. And there was a live before, a previous live that we've done with our bodies, government bodies, and we questioned them. Is there so many reasons or why we have so many acts in Brazil to talk about the same subject and with different regulations? So just for you to have our point of view.
Yeah, I cannot speak for Monica. It was a hell of a job to combine these databases, but it's logical that if you have different authorities, different government bodies that monitor these dams, that you have different systems. I don't find it very surprising. And in the ideal world, of course, everybody uses the same system, but it's not the ideal world. But I'm positively surprised that at least there's so much information about these dams in Brazil, and they're all publicly available. So that I think that's a good thing. I think, but you should make optimal use of it, and you should not blindly trust one system or the other, because when you combine the database, you can see discrepancies. But I think you should try to minimize the discrepancies. And the FEAM and the ANA and the ANM should talk with each other and try to solve these discrepancies. I think that makes sense, and then you can have a better database. But at least you have information, and that's a good thing. But the reliability of the information, and you have to keep the information up to date, of course, also. That's the major challenge, I think.
Yeah, and it's funny because I have some international clients, and they are used to have just one thing to say about the dam here in Europe and United States. And when they are operating in Brazil, you say no, but in Brazil, your dam have 3 different names. But and why? And then they always ask me, but why? It's the only dam. It's just one dam. Say, yeah, but you have different laws. We have different mom and dads of the dams, and you have a different classification system. So sometimes I lost hours trying to explain this combination of laws that even for me, it's too complicated. And I think it's why we need to be so glad to have Marina to help us with this understanding, because sometimes you understand, but you don't understand because it's something completely different. So I have one more question, but now it's more curiosity about the GIS. And I know that GIS is a collaboration tool, and some people can enter there and give more information for a place or for another areas. And I know that in this database, Monica and you try to combine this information, the same system. And what is the risk associated with a bad understanding about these coordinates? I mean, if you didn't have the correct localization of the dams, for example, how you can increase the risk? Because, of course, if you combine this fluid and try to understand the complexity of if all these dams fail at the same time, we have a kind of cross section that it will be common. And if you don't have this coordinates so good, how you increase this risk, because we don't know where these dams are precisely.
I think that the check is very easily done. In GIS, you have we use a GIS called QGIS, which is nowadays it's free. It's for everybody to use. It's very simple to use, and you can have access to all kinds of publicly available information. For example, the Google Maps, so you can plot all your dam locations on top of Google Maps, and you can even browse back in time. You can see in time older satellite images to see if the dam, where the dam was before, or where the tailing facility was before, because they're sometimes very dynamic. So it's basically a manual check of every location of the dam if it's correct, and with all the background information, for instance Google Earth satellite images, you can very easily check whether it's correct or not. So I think that's not a big problem. Only somebody has to do it.
Oh, Marina, and now I'm talking about the laws, but the responsibility of this register, it's from the company, or the agents have the obligation to go there and check for example, the coordinates, the birth certification of the dam.
I'm sorry, I was on mute. The main obligation is from the company to present and to inform the government body about its dam. So that's the main obligation. Of course, the government body has the obligation to make all the inspections necessary to check if it's true or not, but the main responsibility is from the company.
But the agents at some point can check and recommend it that they change?
Yes, if there's a motivation, but it would depend of the reality of what they are recommending. You can discuss, you can argue against, but the government body can and have the power to recommend, of course.
Siefko, do you know, or do you have some idea about the works in Brazil when in this one that you are working like a consultant, international consultant, that people is starting to use the safety factor like a range and not just a number, considering that we have some variety in the site investigation campaigns, in the monitoring and the things from the instruments. Do you know a work that they are doing this?
I'm not aware of it in Brazil, but what's commonly used now is a more probabilistic approach. Like I said, the safety factor is not just a number; it's a probability. Yeah, it's a combination of different probabilities. So a probabilistic approach in the geotechnical stability analysis would be a better way of determining your safety factor, because you can determine what is the influence of the uncertainty in the geotechnical parameters or in your load conditions, uncertainty in the chance of earthquakes, for instance. These are all probabilities. And this is not just one number. With earthquakes, it's not just one peak ground acceleration or one magnitude. It's a probability of having a certain load, also with rainfall conditions. And so a probabilistic approach would be a better approach, but you also need more data for it, and that's always an issue.
Yeah, I don't know if you have this information, but sometimes you need to fight to have one more hole in the site investigation campaign that costs 300 reais. It's
Yeah,
why
yeah,
it's difficult for us have datas, because it's a question. The mandatory sometimes it's cost.
yeah,
So we
yeah,
usually work with less dates.
yeah. And also a challenge is the dams that are what is it, safety level 1. You cannot have access to the dam. I believe so. You cannot do site investigation because the access is prohibited.
Yeah, we still have big challenges, and I hope that you don't have another failure to try to explain more about this challenge, because it's complicated. It's everybody lost a lot when you have failures like this, of course.
Yeah,
Yeah. There's a curve of knowledge and learning, right? Our Dam Safety Act in Brazil has only 10 years. So, of course, there are a curve of improvement that is expected. Unfortunately, we have these two accidents that, of course, no one wanted, but it increased the curve of these improvement and necessary and natural in all changes in the practice and in the regulation. It's natural. Siefko, but I would like to thank you very much. I know it's already late. I think it's 1 a.m., right?
yeah. It's bedtime.
In Netherlands, yes. So I will not I will not prolong our life, although it was fantastic. Again, thank you very much for your kindness. Thank you very much for your presentation. As I told in Portuguese people, we couldn't translate because we are live on YouTube, but we will try to get some way to translate your presentation, our whole video, right? And our discussion for Brazilian people that don't speak Port or English as well, or do not speak it or do not understand so much English, for them to enjoy your excellent presentation. So thank you very much for your time. And Rafa, thank you very much again. I will see you next week. And Siefko, I hope to see you soon here in Brazil, there in Europe, when it's possible, of course. But in the future, when I go there to visit Rafaela and my brothers, for sure, I will arrange a time to have a coffee with you and discuss more about this subject. Thank you again. Thank you very much for you that is here with us late this night, also here in Brazil. We see you. I will speak in Portuguese just for a second. Siefko, excuse me. Pessoal, eu gostaria de agradecer imensamente a presença de todos vocês. Hoje nossa live foi em inglês, mas na próxima semana voltamos para o nosso bom e velho português. Semana que vem nós vamos ter um debate super interessante sobre a regulação que está saindo no forno aí da ANM sobre reaproveitamento de rejeitos e estéreo. Temos duas convidadas espetaculares, a Marina Dalla, da Agência Nacional de Mineração, que está à frente de todo esse trabalho interno da agência, junto com outros profissionais, claro, sobre essa regulação, sobre reaproveitamento de rejeitos e estéreo, e também a Solange Costa, que é gerente geral jurídica de Direito Minerário da Vale, que, obviamente, por razões óbvias, sabe muito sobre o assunto, porque é especialista em direito minerário, também especialista em política nacional de segurança de barragens. Então, o nosso bate-papo será muito bacana e a Rafa estará conosco, trazendo seu ponto de vista técnico, embora a discussão, igual hoje, foi muito mais técnica do que jurídica. Na próxima semana, eu prometo que eu vou dominar mais, hein, gente? Só para descontar da Rafa. O tema vai ser mais jurídico do que técnico, mas, obviamente, os questionamentos de natureza técnica da Rafaela, tenho certeza que virão bombando. Siefko, again, thank you. Rafa, thank you very much. See you next week. Kisses.
Thank you. Bye-bye.